SFUSD, that's the place to be. SFUSD, bienvenidos a Tijuana. SFUSD, everyone come and see. SFUSD, join our family. S is for students, F for families too. U is for united, talking about me and you. S for solidarity, D is for diversity. SFUSD.
Hello, climatologists, and happy Friday. How are you feeling today? It sounds like a lot of you are excited for the weekend. I am too. I plan to sit on my roof and enjoy the sun and my little garden. Last week, I saw a butterfly and hummingbird. They were so pretty. And when I was there, I actually got a little bit sunburnt. There were no clouds in the sky. It was rough, but I eventually healed, and I'm feeling 100% now. Speaking of clouds, isn't that what we were exploring this week? Do we remember everything we've learned? Oh yeah, that's right. We had some young scientists submit scientific questions and we answered them. Let's reread our 2 questions. Why is the sky blue? From a first grade scientist at Lafayette. And are there different types of clouds? This is from a preschool scientist at the SF Public Montessori. Buenísimos. I actually have a 3rd question for us to answer. Let me share it with you. This question was actually written as a statement. This one is from an older scientist. That means they're in 3rd, 4th, or 5th grade. And they're from Dolores Huerta Elementary School. And they said, I want to learn about rain and where it comes from. I like this statement, but can we make this into a question? I think so too. How should we write this question? I really like that. You said, where does rain come from? Great, I'm gonna jot that down. Where, there's still some cotton balls on my marker. Where does rain come from? And we end our question with a question mark. Where does rain come from? So, this question is actually a lot easier to answer now that we've learned about the sky and clouds. We're going to use our knowledge that we gained earlier this week to answer this question. So I want us to think back to Monday when we learned about particles. Let me find my definition and reread it actually. Particle, a small portion of matter or parts. Oh, so particles are parts of something bigger. I was doing some research and I was learning that these particles could be dust, pollen, and even salt from the ocean. All of these tiny particles that are floating in the sky make it look blue to us. So these particles also do something else. They start to collect or accumulate water droplets that are all around them. Let me show you a little model of this that I made. So I have the blue sky here and I already put my particles and I broke up some cotton balls to represent water droplets. So some of the water that we get comes from evaporation, and they get stuck to the particles. And we just accumulate more and more. Maybe it's a really hot day and a lot of water is evaporating, so a lot of it's coming in. And more water is accumulating in the particles. Accumulate. Some more evaporation. Maybe a water park just opened, so more water is evaporating. A volcano just erupted and it heated up some water nearby. So all this water is accumulating, right, scientists? You see it? Awesome. So do you see how all the water droplets accumulated onto the particles? Yeah. What does this model sort of look like now? That's right. It looks a little like a cloud. So clouds are made of particles and water droplets. So now this accumulation or collection keeps going. I'm out of water, but we'll pretend. And at one point, the cloud can become too heavy. And when a cloud becomes too heavy, it releases some of those water droplets. Let's try to show that on my model. So it's a little too heavy, so some water droplets are going to be released. Oh, wait. I think I understand now. Okay, scientists, what do you think is happening when the clouds release the water that made them too heavy? Yes, I agree. I also think that that's how we get rain. So let's go over that again. There are particles in the air, and they accumulate water droplets. After they do that, they become clouds. And when they accumulate too much water, they release it, and we get rain. That just makes sense to me. How about you, scientists? That's great. So we now know why the sky is blue, what kinds of clouds they are, and where rain comes from. And here I was thinking that we got rain because the sun was crying. Ay, ay, ay. I'm glad I was surrounded by curious climatologists. Ooh, I struggle with that word. Well, científicos, that's actually all the time that we have for today. What was something new that you learned about our big blue sky? Oh, cool. Something new for me was learning about why the sky is blue. I had always been told that it was like a big mirror and it was reflecting the blue water. But now we know the truth. Thank you, climatologists, for learning with me this week. I can't wait to see you again on Monday. See ya.
Hello, everyone. My name is Mr. Mansfield, and today I'd like to share a question that San Francisco Loves Learning received. Xavier Miguel wrote, "Is fog a cloud?" I didn't know the answer to that question. It's okay to not know the answer to things. What's more important is knowing how to find the answer. So I researched online about fog, and I learned a lot. Did you know that the San Francisco fog is so famous it's even been given its own name? Carl the Fog. Let's learn about that and more by singing my song, Carl the Fog. Carl the Fog is very famous. Carl the Fog is really great. Cooling all our nights and mornings, drifting through the Golden Gate. Fog is a low-lying stratus cloud in contact with the ground. Here in San Francisco, it always seems to hang around. Carl the Fog is very famous. Carl the Fog is really great. Cooling all our nights and mornings, drifting through the Golden Gate. Fog is made of water droplets, just like other types of clouds. Carl's a symbol of our city, making us all cold but proud. Carl the Fog is very famous. Carl the Fog is really great. Cooling all our nights and mornings, drifting through the Golden Gate. It gets hot in the Central Valley, making all the warm air rise. The cooler air above the ocean rushes in, making foggy skies. Carl the Fog is very famous. Carl the Fog is really great. Cooling all our nights and mornings, drifting through the Golden Gate. There are different variations. Several types of fog exist. Steam fog, ice fog, even ground fog. When it's not around, it's mist. Get it? Mist. Carl the Fog is very famous. Carl the Fog is really great. Cooling all our nights and mornings, drifting through the Golden Gate. Thanks for helping me sing about our local celebrity and weather phenomenon, Carl the Fog. Scientists ask questions and wonder why. What questions about the world do you have? Until next time, stay healthy, happy, and curious. And of course, goodbye, everyone!
Hi, today we're going to read a book named Press Here by Hervey Tullett with permission by Chronicle Books. You guys ready? Let's go. Ready? Press here and turn the page. Everybody take their pointers out. Great, now press the yellow dot again. Perfect. Rub the dot on the left gently. Well done. And now the one on the right, gently. Fabulous. 5 quick taps on the yellow. 1, 2, 3, 4, 5. And 5 taps on the red. 1, 2, 3, 4, 5. And finally, 5 taps on the blue. 1, 2, 3, 4, 5. Try shaking the book just a little bit. What do you guys think is going to happen? Oh, not bad, but maybe a little bit harder. Ready? Shake, 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 shake. There, well done. Now tilt the page to the left just to see what happens. And then to the right a little bit more. Ready? Excellent. Shake the book one more time just to get everything back in order. Interesting. Try pressing down really hard on all the yellow dots. That's funny. Turn the lights back on. Try pressing them all again. Perfect. Hold on. 2 of those dots seem to have switched places. But which ones? Now press hard on all the dots. Really hard. Not bad. Shake them up a little. Pretty, isn't it? Try blowing on them to get rid of the black. Maybe a little bit harder. Oops, that might have been a little bit too hard. Stand the book up straight to make those dots drop down again. There you go, that's perfect. Now clap your hands once. Whoa, clap twice. What happened to the dots? 3 times? 1, 2, 3. More. Woohoo! Keep clapping. Clap with me, everyone. Clap, 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 clap. More. Uh-oh. Too loud. Quick, press the white dot. Bravo! Want to do it all over again? Back to the beginning this way. I hope you enjoyed pressing the dots and shaking the books, and everybody has a beautiful day. Bye.
Peace everyone, it's Miss Sam May from SFLA Dance in Schools and Communities program. I hope you all have been taking great care and are ready to move. Can you believe it's May? May is my favorite month out of the entire year for several reasons. 1, it's my birthday month. 2, you can really see the flowers in bloom when May comes around. 3, it's Mental Health Awareness Month. And 4, it's Asian American and Pacific Islander Heritage Month too. Mental health is super important, as is celebrating one's cultural heritage. In my short time living here on Earth, I found that these two things are actually connected. Having been the first generation of my family born here in America, I had to do a lot of figuring out on my own. With ancestral roots in the Philippines, which is considered to be a part of Southeast Asia, I had to both learn how to be American and at the same time learn about my parents' Filipino cultural values and traditions. Living between two worlds is no easy feat. It can be really confusing and affect our mental well-being. If you have ancestral roots from more than one place in the world, you might feel like you are constantly dancing between several worlds. Here is where your rootedness and sense of balance come to play. So let's be sure we root down and take a few deep breaths together to begin. Feeling your feet planted in the earth always. Bringing your energy from the ground up. Inhaling, exhaling, reaching to the sky. 2 more times, inhale, gathering all that goodness, giving it back, and 1 more time, inhale, and exhale, releasing and shaking it out. In honor of the stars that illuminate our night sky, we are going to become them, and every time you shoot out as a star, go to a different direction every time. Get really small. Ready? 1, 2, 3. I'm a star. Tell them 1 more time. 1, 2, 3. I'm a star. And turn. And turn again. Beautiful. So what does it mean to celebrate your cultural heritage? And what might happen if we don't practice this? I'll use myself as an example. Growing up as a Filipino American, I felt there were many parts of me that I had to understand. It was like a puzzle piece. Can I see you make a puzzle piece shape? Nice. My parents and grandparents spoke to me in Filipino, but at school, I was speaking and learning English. Honoring our native languages is a huge piece to celebrating one's cultural heritage. My parents wanted us to speak English fluently so we wouldn't have a hard time at school. This, however, made it harder for me as an adult to speak Filipino, not to mention my parents' native languages of Bicolano, Kapampangan, and Ilocano. I feel hardness when I think of this because I really don't know if I'll be able to learn all of these languages, but I have even more compassion for my parents and grandparents who had to work really hard on their English when they immigrated to America. Our cultural heritage consists of many stories, histories, traditions, values, foods, songs, dances, so much more. There really are a lot of pieces to this puzzle. From my personal experience, it's when we don't work on the puzzle that we feel like a million pieces spread out across space and time. If we don't work on understanding our cultural heritage, we'll always feel like there are missing pieces to the wholeness that we truly are. Now imagine all of a sudden you realize there are many puzzle pieces all around you that belong to you, that make you you. You feel dazed and confused because everything is scattered. You need each one of them to return to you to feel complete. How do you embody your wholeness dance? How do you find rootedness and balance in this journey of understanding your cultural heritage, your cultural identity? Finding the last puzzle piece to make you whole. Beautiful. Remember this feeling, and even when it feels hard, try to keep at it. Keep finding the pieces to the puzzle. Whether you'll complete the puzzle, that's for you to find out. Thank you all so much. We just explored how you can empathize with others and design your own future. I hope you enjoy the rest of your program. Have a great weekend ahead. Take care. Till next time.
Wash hands now. Wash hands now. Wash hands now. Wash hands now. Hand washing is one of the best ways to stay healthy all year long.
Hi everyone, my name is Adrian. Today we're learning the alphabet. This is the letter A for astronaut. A for apple. A for all the awesome doctors and nurses. A for alligator chomp chomp. Look at that ambulance. So remember, everyone, don't be angry and stay amazing. Bye. I hope to see you again.
Hello everyone, my name is Yasmin, and today I will be teaching you about the scientific method and how scientists use it every single day. So I hope you enjoy it, and let's get started. So you may ask me, what is the scientific method? And it's a method that scientists use to draw conclusions of things they see in the world. And usually there are 5 steps in the scientific method. And the first one would be asking a question. If you are curious about something you see around you, you ask a question. And then, number 2, you make a hypothesis. So what is a hypothesis? It's a prediction of what you think will happen or why something happens. And the statements that we usually use is, I think blank will happen because blank. And the because, it's because you're using evidence to back it up. And that evidence that you use is usually what you see, and you can draw a hypothesis by what you see. Number 3, you set up an experiment where you can analyze what you see, and today I'm going to show you that part right after explaining the next step, which is recording data. So when you make an experiment, you have to record data in order to be able to analyze it, see patterns in your data, and then going to the last step is drawing conclusions. After you've set up your experiment, after you've done your data, you see it, and you see if your hypothesis at the beginning was right or if it was wrong. And if it's wrong, it's totally fine, because many times we learn even if our hypothesis is wrong, and now we know. So these are the 5 methods of the scientific method. So now we will do our own experiment to use the scientific method. And the step 1, which is asking a question, and my question will be, what objects float on water? And because of this question, I'm going to say my hypothesis, which is that I think that denser and heavier objects will sink down in the water and lighter objects will float up. And now we are going to experiment, and I have a bucket of water here and some objects to see what we think it's going to float or if it's going to sink. And first I'm going to drop a rock, which I think it's going to sink down to the water because it's heavier and very dense. So now let's see. It sunk down and it didn't even float at all. So this is proving my hypothesis to be right now. So now we will keep on proving my hypothesis using other objects such as this water bottle, which I think is going to float because of its lightness and it doesn't really have that much density. So let's see what happens. It floats because of its lightness. And next up is another object. We have here a squishy that we're going to drop down to the water, and I think it's also going to float because it's super, super light. So let's see what happens. It floated. So there you go. And we're going to have the last one. This one is pretty kind of heavy, but I think it's going to float because it's pretty light inside and it's not dense. Even though it's heavy, it's not dense. And so I'm going to drop it in the water, and I think it's going to float. There you go. So now you see that we proved our hypotheses. And now that I see which ones floated and which ones sunk, I can prove my hypotheses to be right or wrong. And we draw a conclusion. And so we say that denser and heavier objects do sink down to water, and lighter objects float. And there you go. Thank you for watching. So now you can try this experiment at home if you'd like. You just need some random objects in your house and a bucket filled with water. And you can try it out to see and use the scientific method to draw conclusions. I hope you enjoy this, and thank you for watching.
Hello, I'm Superintendent Dr. Vincent Matthews of the San Francisco Unified School District. It made me so happy to spend time with you today. I hope you had fun too.
What did you make on the show today? Submit your content here using the QR code or go to bit.ly, bit.ly/SFUSD, yes, YES, and watch all of our episodes at sfusd.edu/SF loves learning.
And now it's time to say goodbye. So let's sing our goodbye song. For this song, you have to use your whole body. Will you sing it with me? Are you ready? Wave high, wave low. For now, it's time to go. Wave your elbows, wave your toes, wave your tongue, and wave your nose. Wave your knees, wave your lips, blow a kiss with your fingertips. Wave your ears, wave your hair, wave your belly, and wave your derriere. Wave your chin, wave your eye. For now it's time to say goodbye. Bye-bye.
SFUSD, that's the place to be. SFUSD, bienvenidos a ti, Juan Ying. SFUSD, everyone come and see. SFUSD, join our family.